Hey, this is Steven from Legit Tech Tutorials and Steven's Classic Garage. Today we are going to be talking about the DIY Dyno build. So let's go ahead and check that out and see what we can do here. In the last video you saw that we ran out of basically the we didn't have the moment of inertia that we needed. So there was another roller at the metal store that was bigger in diameter. I think it was like something like 18 inches or something. So let's say that we had that, which is, as you saw on the Dyno Jet, that's a pretty popular diameter. So let's go ahead and let's open another one, and so let's see if this is enough. So the idea is that those the ballasts on the inside are not going to work, mainly because the issue with the flywheel is that in the center it doesn't really do much of anything. So it's just a lot of weight for the amount of moment of inertia it gives. So in this video we're going to look at the 18-inch diameter roller, and we're going to look at how that affects, and then we're going to do some analysis on that, some static analysis, and see if that's going to cave in on itself. If we, for example, held it on the inside. Obviously we're going to need something like this on the outside here, but it'll probably be very thin, and then just have a bearing bolted to it. Just a bearing, there's a certain name for the block. They have the bearing block that goes around it. And then that's just going to be bolted there. So, let's go ahead and do another one. Let's make these 18 inches. Oops. And let's say it's also a 1/4 inch. I think it's probably more than that, but let's just say that it's inwards negative 0.25. And then let's say that it's 2 feet. Man, I forgot to bring my tape measure again. But 18 inches is not a small length. I mean, it's 6 times the size of a caliper. So let's say this is, so here's 6 inches. Here's 6 inches. Here's 6 inches. So it's about that. I think that'll work. And then, 18 inches by, let's just say 2 feet again. We could drop this if the weight is too much. If the weight for 2 of these guys is too much, I'm pretty sure the thickness is going to be more than 1/4 inch, but we could still test it. So let's go ahead and go here. Let's change from body. We want to physical material, as always. Change from metal to A36. And then this we're going to call Roller V3. Now, let's go ahead and look at properties, moment of inertia, and remember it's that center one. What? What? Properties, moment of inertia, center of mass. 51,912 pound mass. That's pretty high. And we have 94 pounds. So, with that, we cannot do, this is probably going to have to be 18 by 18. Oops. Or maybe even 16 inches. because it's too heavy. 71 pounds even then is too heavy. Then we would need somewhere to store it on the floor, basically. Or what we could do is we could change it to a single roller, right? Obviously there's going to be way more stress on this roller, and then also how we're going to keep it there is going to be hard. So maybe we'll have a single roller, and then maybe we'll have some smaller rollers here that keeps the tire from moving off of this roller here. That keeps it onto the roller, basically. Yeah, so here we go. We're looking at 71 pounds, and we have a moment of inertia of 38 pound mass. So let's go to our Swift Calc. This is way more because we went from 13 to this. So this is probably what we're looking for. So if we have two of these, and it's 40, then it's 140 pounds, but that's 18 inches. That's probably the smallest I would go, honestly. And the other thing that we could do is we could change this to maybe some sort of aluminum pipe. If there's aluminum pipe, we could drop the mass and keep the diameter large, but we're going to increase the amount that we're paying for this roller itself. Because I could probably get this really, really cheap at the place that I would get this. So here we go, Dyno. Okay, OD, let's say 18 inches, and ID. ID is 17 inches. Oh, sorry, 17 and a half inches. There I had 15 inches. Biggest tire I'll probably run again is 300 millimeters. 300 millimeters, about 13 inches. So, I guess 15 inches would work, but let's go with 18 for right now. Because again, mass doesn't really help you much at all. So, here, yeah, 71 pounds is about right. 143 pounds total. So this thing's going to weigh next to 160 pounds. Moment is 40. Moment dual roller is 11,000. So we're looking for Dyno sizer. So here we go with the Dyno sizer. And let's say that this is 225 pounds. And this is 500, and this is oops, and we have here, we want something that is 112, and 5.9. Oops. So even then, only 0.62 flywheel weight, 160 to 164 pounds, which is what ours actually weighs. Interesting. Well, close. But that's for two. This is only one flywheel. So it's still very, very low. So another thing that we could do is we could increase the maximum of this flywheel RPM, but as we increase the diameter, RPM is going to drop, right? And so you get a longer full pull to go from really low RPM to high RPM. So another thing that we want to look at here is let's do, so here we have rim tire thickness and stuff like that. So here max torque. And after we've done that, we want to know max RPM roller equals, so let's say we have red line, engine red line. Let's put a variable, let's put a slider. Engine red line, RPM, and let's do 8,000 or something. Let's say that this is 10. So let's say engine red line on the Mustang is about 5,000 RPM. It's close enough. Okay, and then let's say okay, so now we have red line. Then we want to know, so we have the tire diameter, torque radius, which is this. So torque radius, basically we want to know the circumference of the tire. Tire circ equals pi times torque radius times 2. I don't know why it always does this, man. Tire circ. Okay. Tire circ. Okay, so there's a tire circumference, and then we have roller circ equals OD times pi. Oh shoot. Roller circ. OD times pi. And then we're going to assume that last gear is 1-to-1, let's say. So last gear is 1-to-1, and that's going to give you the slowest pull, and you will see less gearing loss and stuff like that, because basically it's going straight through. So obviously you have the differential if you have a rear-wheel drive car, but most cars you'll see that'll probably be the slowest acceleration and the most time of the car accelerating. And then if you could have extremely high spinning bearings on the rollers, then you're okay. And as you increase the roller diameter, the rollers spin slower and it's not as scary. So roller circumference, roller RPM max equals, okay, so we'd say, okay, so how are we going to do this? Okay, so we have RPM, inch, so well, basically it's just the difference between the, wait, what? Whoa, the roller's bigger than the tire. I was about to say the roller's bigger than the tire. What? Why is the rim size 10? That's not right. 14, there we go. So roller max RPM is basically engine red line times basically the difference between the tire circ tire circ divided by tire circ divided by roller circ. $5,274 RPM. Now, if you go with a bigger rim, then you're going to have less speed. But also that depends on, but that's not necessarily true. Because then you have, the next thing you have is you have rear gear, right? Rear gear. And here I'm going to have 1 be minimum value and maximum value be I don't know, 30. So my Mustang, I believe, so Mustang (1965) Mustang rear gear. A code, C code. Because I'm pretty sure I have the 280. Pretty sure I have this one. Also, mine are standard open. Well, another thing I could calculate is, then it's dependent on third gear. And then I would need to know the code on third gear to figure that out. I was going to say I could go with third gear and see at 2300 I'm going 65 miles an hour, 2300 RPM. I mean, that's what I remember for sure about my car, but let's say that this is 280 to 1. And it's a bigger gear to a smaller gear. So in actuality, that motor is spinning the back tire faster because it's supposed to be a smaller pinion gear, bigger input gear. So it's actually going to make it faster. So, what did I say it was? Oh, sorry. So this is not large. This is, say, 3.01 uniless, 2.8. So here, and then this is also an option to go all the way down to 1 if there's no rear gear. So roller RPM max times rear gear. Oops. Oops. What the heck, man? Oops. Hmm. '65 Mustang 289. Red line for 289. So it's about 5,000. Okay. So yeah, I mean, obviously that's way too high for. There's a slight ratio here where this is slightly bigger circumference, so. So it's going to be spinning this thing like a crazy blender. Okay, so. And we are at. So where are we at again for the dual roller moment? 11.11284. Really close. And this is each side, so if we could get both sides connected, then it would work. So that would be 22. Let's say. Okay, so say 11.8 by 5.9. It's 3 seconds. It's just not enough inertia for the weight. It's just going to be too heavy to push around the garage. And I don't really have a good spot for it, because these things are decently big. The only other thing I could think of is like the cheapest is like a drum brake system, but then the brakes are going to change depending on heat, right? I mean, they have a general rule of thumb, but it's not very accurate. So, I mean, we could do some sort of mechanical high pressure water pump of some sort. 100 psi, 8,000. So another thing, one of the things I saw is I was over here at Harbor Freight, right? I saw one of these. Let me see if I can find it. But basically, they have a belt-driven compressor that you don't need, that doesn't come with a motor, and then you just go over there and you attach a belt to it, and oh, here it is. This is basically what it looks like. And this guy is a 5 horsepower, so it should take 5 horsepower, but it really depends, because at 145 psi, and then at 15.2 CFM at 90 psi at 1,000 RPM, and then so that'll all depend on this pulley, because then you'll have to downgrade this thing to a lot slower than whatever I was planning on doing. But really, air is not as doesn't require nearly as much energy as water. So maybe we could do some sort of pulley driven water pump, some sort of water break of some sort. High pressure, we want extremely high pressure. Let's see what Alibaba's got. Let's see if they have a Dyno water break. Wow, 3,000 horsepower. Let's go ahead and show you guys these. So these are kind of like high pressure dyno brake. Hmm. 270 to 805 horsepower. Okay, so I wonder if they have any sort of Alibaba ones. I know water break. Because basically this, but I mean, you could kind of make one. Basically what you need to do is you need to do this. So I'll show you. What was this one? Or I have an idea. That's brilliant. Okay. What about this? What if we made the component change weight? Right, so it's light at the beginning, but then it gets heavier. This is my idea. So what if we fill this? What if we put ballasts in here? And we fill it with water. So what if we had a bucket? Almost like a bucket, obviously a steel drum. It has to survive a weight of a car. And then we filled it with water. We fill these different sections with water. And then that'll drastically increase the weight of this thing. So let's say that we had this, and then we did this, where we had this section, and we offset it with this section. Oops, not offset. Not that. Project this section. And let's do from here up. And so this is a decent idea. This is the cheapest way of doing it. It's going to increase the weight a lot, and also that means that the bearings are going to have to be more robust, but it's a way of drastically increasing the weight of this thing, right? But you're going to have the bearings be able to sustain this amount of weight. So new body, distance to object. There it goes. Okay, so here's body number 2, physical material, and close this, liquid, water. There you go. Now what is our weight? Our weight's probably going to be very, very heavy. Properties. About 227 pounds, so it's about 400 pounds. Then you need a way of draining it, right? But, you know, we could use a smaller wheel than this. Obviously, it's going to spin faster, but now we've drastically increased the weight. And then we could drain it out, and let's say we use a smaller diameter, and it's easier to carry around. So now you just take it and you fill it full of water, and now it should have a very, very large moment of inertia. Now the issue obviously is filling it with water, basically all the way up to the top. That's the issue, is that you can't have any sort of opening, right? You have to fill it all the way up till it overflows and then cap it. So you would have to, you know, turn it on its side most likely. So that's another thing, is getting it fully filled with water. Okay, so now it's 80. Ooh. So we went from, where is it? We went from here, which was 40, to 80. So now we're at 160. So 40 into 80. So now we're at 160. Sorry. So yeah, 80, 160. So 160 here. That's 4 times this. That's 44. Let's say 45 inch pounds. 45 foot pounds. Sorry. It's 45, yeah, inch squared pounds. So, inch squared pounds. Nice. So now 14.1 by 5.9. Okay. So now that's better. And then, but you have the caps at the end. You have a cap on one side, cap on the other side, which I do not have right now. So that, I think we could do something with that. Because the other thing I was going to show you, we have a couple minutes, I'll give one more minute here, is Okay, so basically this right here. So basically what it is it's a drum, and then you have a flap, right? And then the flap goes around and pushes the water around, and it creates a lot of resistance. So basically what's happening is this water has a lot of resistance against the side of this bucket. And that resistance is the friction between the water and the side of the bucket. This is basically how a water break works. I mean, this is basically a pump, right? So this is basically identical to how a water break works, except for you're doing your own one, right? Kind of a lower pressure one. You're not actually doing any pressure. You're just using this flap wheel to agitate this water and move it around in circles. And you can see how it looks like inside. It's simple. It's just two flaps, right? And it just goes through and just agitates the water. Alright, so I'll have to think some more about this. We will talk more about it next week. Thanks for watching. Take it easy. Peace.